All right, hello. Ian and I's project was um, machine learning models to predict future salaries for MLB players. And so we applied machine learning models to predict MLB players' salary for the next season. And we did this using historical data and statistics. And this can be either previous salaries, batting and pitching statistics, demographics, and position. Um, we engineered the target variable salary next by shifting salary forward 1 year and then constructed player year futures from prior season information. And these are the hitting and pitching statistics that we used. So they were OBP, which is on base percentage, how often your hitter is getting on base, um, slugging percentage, which gives each hit its own weight. So your doubles, triples, and home runs are going to be weighted more than your singles. Um, OPS, which is on base plus slugging. Um, Ks per nine, which is a pitching statistic, which is just how many strikeouts a pitcher gets per 9 innings on average. WHIP, which is walks plus hits per inning pitched. So this is also a pitching statistic. So it's going to add your hits and your walks into one. Age in years, and then the experience in the MLB in years as well. So we compared three supervised regression models, that those being KNN, Random Forest, and XGBoost. We found that the Random Forest performance did best overall, with XGBoost coming close behind, and then the KNN performed significantly worse than both the Random Forest and XGBoost. So to get into our methodology, the data we used was from data from 1985 to 2014, and then the data between 1985 and 2011 was being used as the training set, with data from 2012 to 2014 being the validation set, and then predicting the salary the next year. From prior season performance, we engineered key rate and workload metrics as listed in the abstract, and one hot encoded categorical attributes such as primary position and the way the player bats or throws, so right-handed or left-handed. In order to handle missing values, numeric features were median inputted. This replaced missing value with the median of all other values in that column, and then standardized via z-scores. We compared KNN, Random Forest, and XGBoost regression models using RMSE, MAE, and R squared, and trained a logistic regression classifier for top quartile salary evaluated with ROC and area under the curve.
So to get started, after Toby explained the abstract and methodology, across our test seasons, which was 2012 to 2014, the tree-based models very much outperformed KNN for predicting our target variable. Random Forest was the highest accuracy model with a root mean squared error of $2.16 million. Mean absolute error of $1.12 million and R squared of 0.83. XGBoost was a close second with RMSE of 2.24 million, MAE of 1.13 million, and R squared of 0.82. So XGBoost was just about as viable as Random Forest. KNN fell a little short of those two. The root mean squared error for KNN was 3.4 million, which is a significant increase from the other two. 1.88 million for MAE, and R squared was only 0.58 compared to 0.83 and 0.82. And the plots that are shown at the bottom here, between the regression model comparison and the top feature importances, are the actual versus predicted line of best fit scatter plots. And you can see that the Random Forest model fits just a little bit better than XGBoost, not by a mile, but it was noticeable. Um, and that's kind of how we, I mean, aside from the numbers themselves, that's kind of how we decided that Random Forest was the best performing model. And then just to touch on our logistic regression ROC curve, the area under the curve was 0.94, which was really good, better than we were expecting. And we, upon doing the study, found that the previous salary, or sorry, not previous salary, current salary was the strongest predictor of the future salary, which you would expect. And the following most important features were experience, which is the number of years they've been in the MLB, and the careers and career achievements like All Stars and awards. And just to summarize, um, we trained our model on 25 years of data, or 27 to be exact, um, and then validated it on 3 years of data. And we came away with saying that you can use these models to viably predict salaries of MLB players, and it poses a lot of bright opportunities for the future for general managers and coaches and front offices of professional baseball organizations and minor league baseball organizations as well, to get a better idea of what they might be paying their players in the future, what the market might look like for certain positions in the future. What a player is worth based on their performance, based on their career, based on their age. All these different factors play into a more accurate prediction that will only get better with the more years that the data is trained on. So as we advance into the future, it's only going to get better and more accurate. And just to explain the other graphs displayed on the poster, the regression model comparison is just it's just a graph of root mean squared error in dollars, and KNNs is significantly higher than Random Forest and XGBoost, but Random Forest just so slightly edges it out as the victor. Top feature importances, which I touched on earlier, you can see our variable name for current salary was the most important, followed by the log of salary, current salary, and then by experience was the next closest. But current salary was by far the most important feature in predicting future salary. And then you can see our ROC curve for our logistic regression model. And you can see the area under the curve number there. We rounded up to 0.94, but the actual number is 0.938. And yeah, those were kind of the results of our project. And yeah, just to give an overall summary, Random Forest performed the best out of the three models we tested. The logistic regression model did a great job of predicting high quartile or top quartile salaries. And this could be a viable strategy for real world scenarios. So, yeah.